right. Ladies and gentlemen, I would like to bring our next keynote speaker, Professor Ian Jefferson. Professor Ian Jefferson is a professor of geotechnical engineering and the deputy head of the College of Engineering and Physical Sciences at the University of Birmingham. A graduate of Loughborough University, where he also earned his PhD. He has over 30 decades of academic experience, spanning Nottingham Trent in Birmingham, and his expertise lies in soil behavior, sustainable geotechnics, and infrastructure resilience. Professor Jefferson's leadership and research has significantly advanced the understanding of geotechnical system, contributing to innovative approaches in civil engineering education, sustainability, and the performance of ground and foundation system. Professor Jefferson, thank you so much for honoring our invitation. Absolute honor to have you here today. Professor Dr. Elena spoke so much about you being a mentor to her. So we're really excited to have you here.
Thank you very much.
Yeah. So would you like to share your screen, or would you like me to share your screen for you?
Hopefully you can see that okay?
Yes, we can, although it's still...
It's got to go back, yes, right. Okay.
Yes.
Okay. You want me to start?
Yes, please, Prof.
Okay, well, thank you very much for that kind introduction and Helen's words. That's a great honour. It's wonderful working with Helen and other colleagues. This talk is really follows on from my colleague, Professor Chris Rogers, who would have touched on a number of things related to urban developments. And from a sustainability point of view and integrating people, planet and policy, clearly a real challenge is how we embrace the urban environment. We all know that populations of the world are becoming more urbanized, with figures quoted between 60 to 70%, depending on which country you're in. So there's some real challenges to ensure that the future living is made in a more sustainable way. And coupled to that, of course, there's the challenges of climate change and how we both mitigate and adapt to those challenges. So this talk will very much focus on work that we've been doing at the University of Birmingham and other places with colleagues like Chris Rogers, related to how we can help that in the urban environment. I think we all know about transportation, we all know about buildings, and we all know about energy proficiency and all those sort of things within that context. One of the areas that's often neglected is how we use our underground space. In many urban environments, the underground space is very haphazardly used, and it actually is a great resource for a whole host of things of how we can make our urban living more sustainable in the future. So this just shows you an evolution. It's very much a UK perspective, just to illustrate the point. But we've used our underground space in a variety of ways through ages. And the first picture on the left is pre-industrial age, where we were using our underground space for water extraction, mineral extraction, and obviously waste, particularly human waste disposal. And that was very haphazard, and it was where local resources and people didn't really understand how that interacts and how that works. But there were certain elements of symbiotic relationship that worked, but often didn't because of the haphazard nature. As we went into the industrial revolution and urban environments, we moved to the middle picture where we started to use the underground space in a more meaningful way. And you can see that middle picture shows examples of how that was used in urban environments. There's basements. You'll see there at the bottom there's a tunnel where the steam train's going through. London Underground is an example of that. There's other pipes that were starting to introduce to deal with water supply and effluent dealing with. But it was really much at the dawn of how we utilize that space. If we now go forward in time to the modern day, the picture on the right shows you how it's much more interactively used across a range of different areas, from foundations, from parking, from basements, from storage, from energy extraction, mineral extraction, utilities, transportation. And in some parts of the world, you'll see in another slide, there's other uses for this space. This space has a number of advantages, but if we don't plan for it properly, we're going to end up with problems of how we're not using it in a more sustainable way, and that would be a great shame given its potential. So what does the future hold? And I think the future will enable some of these areas because it has great potential to meet the sustainable and climate change adaptation challenges that we face. And here's an example of probably where we are and where we're going. The underground space in the urban environment, probably the top 50 meters or so is what we're talking about. And you can see a variety of in that three-dimensional sketch there. And the one on the right shows you the complexity of the challenges. What we've got, though, is a number of aspects that are happening in our current climate change. And often what we're seeing is a change in the water table in the ground, both with it decreasing and increasingly in a number of areas, such in Western Europe and the UK, and here in Birmingham, the groundwater table is rising. That presents a challenge to the assets we've got buried in the ground, and that needs to be managed. So an example would be in London, the underground system is now at a level where the water table has risen above and it's presenting problems of controlling that ingress into the transportation system. So a number of challenges how we mitigate the current and future climate change impacts that we're facing. Handle these correctly, and I think we've got a great opportunity to utilize that space in a wonderful way for our urban futures. So this just shows you some examples of around the world where underground space is used in a much more versatile way. And some of them you'll be familiar with, some of them are old, so the air raid shelter clearly is from the Second World War. But you'll see a lot of it's to do with utilities and utility infrastructure. So the bottom right shows you a typical urban environment. It's actually quite haphazard, and I'll show you another picture of that shortly. But there are other potential uses for our urban environment, and this is where the future potential comes from. So you can see there, there's energy provision, there's water provision, there's sanitation and doing that in a way. That could be a local supply, so having a water system where a tank is buried in the ground in each household to capture rainwater, so a good rainwater harvest, so we can actually reduce the amount of central water supply that we need. We can use it for other aspects, so there's a number of areas for retail and entertainment complexes, so underground cinemas. We can use this for operating theatres. It gives a controlled environment, and that could be a particular way. Living, and you've seen some examples around the world where we're actually utilising it. Why? Because the ground provides a thermal stability. We're not having the same extremes that we were above the ground in terms of thermal control, hence reduce our energy demand. And there's some areas where we distribute both on municipal waste and distribution of that to collection points, so we avoid the need for transportation, for dust trucks and others to collect the waste. And in some extremes, as an example here on the top left of McDonald's, where they actually come up, you order it, and you drive up. And I'm not quite make out that, but there's a little chute there where you actually, when you get ordered, it comes up and you collect your food from there. So there's a number of ways we could utilize this space, and of course, there's plenty of examples of how this is working globally. The problem is we need to understand the ground, and the underground space is a hazard. And a key thing to how we're going to manage sustainable practices and mitigate for climate change and adapt to it is we've got to understand the hazards we're dealing with. So risks and hazards are very much at the foremost of what we're going to do if we go forward and understand the consequences of that. Here's some examples of where the underground space has failed. The one I'm going to note here, this was actually at Heathrow, where the Heathrow Tunnel Express from Paddington to Heathrow Terminal 3 was built. The way it was built, it was insufficient to take the loading during construction. It failed. It opened up a huge chasm, and it was propagating out. And you can see the damage it's caused to a building here. The risk was to actually creeping forward to where the runway was. So the solution was they had to pump it forward very quickly of green concrete to stabilize it. And so if we don't manage these and understand these and engineer and plan for these risks, we're going to have a number of serious consequences, which cause both neglect all the work we're doing, but actually to cause further problems. There is a problem we have, though, within many urban environments, is that we tend to hide our assets in the ground outside our mind until they fail. So again, goes back, talks the same thing, where we've got to understand what we're dealing with and managing it if we're going to achieve the requirements we need. This just shows an example. This is from the turn of the 20th century. This is New York, but that's the sort of environment you can get if you don't plan for your utility properly. Now, there's a whole haphazard arrangement and a number of challenges with that. Clearly maintaining it, and if you have to repair it, that's going to be a huge consequence. And you think that's 100 years ago, we're still making the same mistakes to this day in many environments. And there are solutions that to overcome this, but of course that comes with an investment. And so we need to move to an investment cycle that looks over the life cycle of the assets we're putting in for the use for future proofing, and we need to invest in that. And I think we've now gotten the case where, with climate change, with carbon, with other aspects that we need to take account of, the business case becomes a bigger piece, and that will be an enabler to make sure that this can happen. Up to this point, the cost of the initial investment has been an obstacle, and that's prevented some of the solutions that we know can work in this context. This is an example of a solution. So what we've got on the left is a picture of a multi-utility tunnel where we actually bury these in modular units, which have a number of advantages, which I'll touch on later. But the key thing is we can access these utilities to maintain them and maintain the integrity and adapt them should future needs require it. Now, there's a number of aspects there. This is for utility. We could have other things in that space. The 4 pictures on the right actually are taken from the University of Birmingham campus, where we actually have such a multi-utility tunnel across the campus. And this has been transformative, the way that we keep and maintain the utility supply for the campus. Clearly here, you can see here, you can see the container, and you can see the units, the slabs that go on. This is in the road, this is down by the civil engineering laboratories. What this means is these slabs can be picked up quickly without having to dig up the road. We can go in and repair or maintain or add or whatever we need to do to this utility. It's in a safe, clean environment for people to work in. We put it back, and so we minimize not only the financial costs, but also the other add-on costs that we can get with these things, both from an environmental impact, but also a social impact. Because if we have to dig up the road and cause traffic delays, that has a series of implications, including the social one, which is often forgotten in the sustainable discussion. At the University of Birmingham, we've opened up the National Buried Infrastructure Facility, and I think my colleague Chris Rogers would have talked about this. And this is where we're doing a number of projects to look at this, but very much driven by climate change adaptation and mitigation and sustainability, looking at the testing and the verification. And that shows you some of the facilities. And I want to go to this one, where here is a ducting unit for drainage. But what we offer here is the verification and compliance testing to ensure that these are fit for purpose, because the adoption of these more sustainable, more recycled products within these sectors need certainty. And the construction sector particularly is very, very conservative. Without that verification, people will not adopt these practices, processes and products to be in a more sustainable way. Here we got an example of a new material being used. It doesn't look very exciting for the non-initiated. It's very exciting from a geotechnical point of view, but that's using waste materials from construction waste to build platforms to build on. They would traditionally not be accepted because they don't meet the standards, requirements and compliance. The testing at places like NBIF allow us to give that verification so they can be adopted. That has a huge saving on primary aggregate, a huge saving on transportation, and that therefore contributes to the sustainable agenda in a number of ways. The other here is use of plastic and proprietary projects. This is glass reinforced plastic products used in the railway sector for drainage. This again, verification sector. We can do it through a digital twin. So the capability of using digital allows us to do the verification, giving us the tools to make sure that we can actually, over the life cycle and a holistic systems approach, actually embed better sustainable practice in what we do, both now and into the future. And the one here on the top right is just the next generation of quantum sensors that refines the way we visualize the ground, giving us the information to make sure that we're actually in a better place to actually undertake the work that's needed to achieve these goals. A number of aspects here. There's a lot of work being done on visualization. So the use of numerical tools, the use of digital tools, but also the use of modeling and increasingly of AI as a predictive tool to build up a picture of the characteristics of the ground in the urban environments, both from three-dimensional modeling, but also increasingly four-dimensionals, allowing that time dependency impact to take place. Because what we're building, if we want to make it fulfill the circular economy and other longer-term aspirations, we need to know how it's going to perform over the life cycle of its use. and this could be anywhere up to 120 years. Then build in how we can recycle it to ensure we get that circularity built in. We need to know what we're dealing with. Clearly, natural deposits from an engineering point of view, we have some understanding. The anthropogenic or human-made materials are obviously much more complex and a real challenge. Often they're found in urban environments. Often that has a number of other consequences from construction soil and other areas, which affects the urban soil health. And that opens up, if we can improve that, a whole raft of things in terms of greening urban environments, but obviously a potential for urban farming and other aspects that help solve other sustainable challenges. So hence, taking this holistic, sustainable view to address some of the key challenges that bring everybody together under the banner of people, planet, and policy. One of the recent things, I was just in a conference talking about modular construction. Modular construction is where we build our buildings, our building units off-site in a factory and a controlled environment. That has a number of advantages to our traditional on-site construction. Not only is it safer and more cost effective, it also has the benefits from a sustainable and environmental impact point of view of reducing waste, reducing carbon, reducing energy, and the more raw materials. And you can see the schematic on the left shows you an example of the sort of percentages we often see for these units. The figure on the right shows you a unit being built. You can show that interchange with sensors. So it allows us, if we're building offsite, to build in sensors and smart monitoring systems. So not only can we actually build it better and greener and quicker, we can also manage that system in a more sustainable way. Because in some respects, the construction industry is responsible for a huge percentage of a country's carbon. Not only just from the building material, but actually the products that we produce are users of carbon for heating, cooling, lighting, etc. If we can improve those, we could have a big impact on the carbon and hence the climate change problems. There are a number of opportunities there, and they're listed there. You can see those there, and there's some exciting technologies we can use in terms of smart technology, use of artificial intelligence to drive a systems-based approach to ensure that we optimize our design. We can building management systems, we can make sure we build safely. So a key thing to remember is that sustainability, the social aspects. So we have to do what we do safely. And the key challenge for the construction industry is building safely. It's a dangerous sector. That's where robotics can come in. And some of the challenges are shown there in terms of what we need to overcome. And the problem with is the business case, and why there's been less of an uptake over time with this is there's a large initial upfront investment. There are transportation, there are governance issues, the standards. But I think now is the time is to get the right alignment of the stars, so to speak, where the case for doing this outweighs the cost from a purely financial point of view. So I think it's quite exciting that the ability to build these things in a safe way is outweighing the cost. And these will actually, as you saw in the multi-utility tunnels, helps us make the case for the multi-utility tunnel more effective and hence more likely to adopt. And we're talking with Birmingham City Council about how they can do in some of the developments around various locations in the city. And a number of cities are embracing this and seeing the long-term benefits of those systems. So you can see the system approach of how we use the right construction methods to deliver the products that allow us to operate in a more sustainable way to mitigate and adapt to the climate change challenges that we face. That shows you a schematic of a future urban environment where we're now embedding these things, and we can integrate this as a systems-based approach, taking account of the demands from the users of the urban environments, people, the distribution of the resources and services that they need in a efficient, safe, and more sustainable way. And there are a whole raft of things that come in there. And the opportunities of how we use the underground space are really huge. And it's something we need to embrace if we're actually going to make our urban environments more sustainable in the future. Clearly, whatever we do is about people. And the picture on the left is just a picture of people, but we actually work together to make sure that the products of what we're doing are working with different parties and disciplines in an interdisciplinary approach, cross-disciplinary approach, to ensure that what we're producing within the sector I work in this case construction, is fit for purposes both within the short term and long term. And that's where different disciplines need to come in and work together. So I've done a lot more work in recent times where we actually bring that systems collaborative approach to bear on the challenges that we face, to set out in a number of areas. I think we can do that, and I think I'm seeing around the world in many countries a drive to do this, driven by governments and other organisations. I think we have got the solutions, and we're starting to see the benefit of this. So I think we're starting to turn the corner. That was just a brief go through of some of the challenges and I think some of the opportunities that urban underground space provides us. I mean, there's a whole raft of things in there, but I'm happy to take questions to it. But thank you very much.
Thank you. Thank you very much, Professor Jefferson, for that fascinating and forward-thinking presentation. So, Professor Jefferson, the first question, you mentioned using smart technologies and artificial intelligence to drive a system-based approach. Could you expand on what system-based design mean? Like, what system-based design, what does it mean in practice, especially in the context of sustainable infrastructure planning?
Basically, it's early discussion with all stakeholder parties to make sure that all parties feel into the start of the design process. Because otherwise, if we don't take that approach with all parties coming in and feeding into that overall aspect, we lock out a lot of the solutions that could provide the sustainable solutions we need. So if you think of a building, the systems approach is not just thinking about having the person design the structure, somebody building the structure, somebody coming in to put the electrics in, somebody to put the water in. What we're talking about is everybody talking together so that they can make sure that what they need is fit together in a complete package. And often what we find in construction sites where there are problems is we do it in a piecemeal approach, where the parties are not talking to each other. So the classic thing is that we're taking a utility trench. If we dig a utility trench for water, we then fill it back up, and then they dig it up again to put electricity cables in. So the system approach is, we know we're doing this, we'll leave it open so you can do your bit. So it's making that joined up thinking so we don't trip over ourselves and take a lot of time, cost, and expense and impact sustainability in a sustainable point of view to meet these challenges. So it's that holistic joined up thinking.
Thank you very much. That was very, very profound and very, I mean, the way you've explained it so simply. Thank you so much for that. And also, you reminded us that the social dimension of sustainability includes building safely in what is still one of the most dangerous industry, obviously. Yeah. And how do you see robotics and automation changing the culture of safety in construction, not just the statistics?
Oh, fundamentally, because I mean, UK has had the governance to make construction safe. So it's one of the safest construction industries globally. But construction is still a danger, and I've had experience where people have had injuries and we've seen deaths, unfortunately. What robotics does is allow us to get robots to do the construction where we wouldn't want to put humans. A really extreme example of this is Chernobyl. So some of us will know that the Chernobyl nuclear reactor exploded in 1983. It's currently been decommissioned. So what we've actually done is they've built a great big concrete dome to make it safe to the outside environment. Inside are robots that operate in extreme conditions to decommission it to make it safe or reduce the risk. So we can use robots to actually go to places where we don't really want to put humans. Deep in the ground, across bridges, high up, wherever you want to put it. But that would be transformed to the way we do this. So that almost there's remote and also autonomous systems. So one of the projects we're working at Birmingham with colleagues at Sheffield and other universities is using pipe bots. So they're little small robots in a swarm, like an insect swarm, that scurry up and down the pipes to check the maintenance of the pipes, check their integrity, and then repair them. For that human to do that, we've actually got to physically get in there and go down, which is extremely difficult and potentially very dangerous. So those are examples of what we can do.
Thank you very much. And you spoke about, when we're talking about cost and investment challenge, you noted that high upfront investment remains a major barrier. So what innovative financing or policy models might help us accelerate adoption of the safer, smarter technologies, especially in the global south and in developing nations, or even for smaller contractors?
Partnership. I mean, I'm not a financier, so you had Hishan on
Yeah.
earlier, so he's better placed to say this. But I think it's partnership and collaboration. I think where we see a lot of the business cases not working is we're not actually looking at joined up thinking. So where we can actually put the business case together. I think understanding the longer term consequences, and it's a lot of the procurers of construction are actually governments. And they have the ability to drive the change in this space. And if they can do that, taking a more circumspect view and make the business case not just about the financial thing in the capex aspect of the work, but looking at the whole revenue and life cycle of this, I think that will help. I think I'm talking to some examples, talking with Birmingham City Council, a council that is not exactly flush with cash, but they are now investing in discussions about this because they understand that it saves money over the life of what they're doing as a council. So it's making those arguments land. Our traditional model obviously is very short-termism. If we can take a view where we're getting people in, so a design, build and maintain type contract, where the person building it and designing it is responsible for the maintenance and they've got that longer term aspect, they've got some ownership, that will help engender that. Now, we've had examples of this in public-private financing and 25-year asset contracts, and they've not worked very well. So there's a bit of work that Hishan and his colleagues need to do to incentivize this, particularly in a complex contract arrangement such as construction. And I know some countries are looking at their contracts to move away from the more adversarial approach that traditionally sits within contract of construction. So there is some contract changes going in many parts of the world. So it's doing the work at that level to incentivize it and motivate and provide the levers to make it work in the right way.
Thank you, Professor Jefferson. So let's imagine we're in 2035, so 10 years from now, and you're standing on the smart construction site. For you, what does it look like? And how have people, robots and data system, how are they working together? And what does that mean for sustainability?
Well, for sustainability, it means what we're building is going to be more sustainable and better and using better materials. I mean, there's a downside because obviously we've got to think about the people that are employed in these more traditional roles, and they have to be, there's a whole skills and upskilling that. So let's not forget the human side of the impact of this. What I think it means is that we're going to have there's an opportunity to be innovative in a whole raft of different ways. A lot of that is there, but we don't do it in a way that makes it work because the business case doesn't stack up. This will be an environment where we are using the novel materials, we are putting the sensors, we are producing the smart operational procedures of the product of construction. We're building it safely, we're building it in proper time management. We understand the interchange complex systems because we're using AI generated tools to manage the optimization. So a whole raft of things that makes it more efficient, safer, more sustainable, and ultimately better product for everybody to use. So yeah, I think it's bright. I think there's a challenge to get to that point. 2035 is not that far away. We've done some work where we looked at 2050, but and we've got to manage expectations. I know in some countries around the world, they're quite a bit advanced in this area, but there's interesting that the way they do things is slightly different. So there's still a complication in that arena and how we manage that. So we're on a journey, very much so, but we're going in the right direction.
Thank you very much, Professor Jefferson. And you reminded us today that sustainability is not just about carbon or climate. It's about people, it's about safety, and it's about design integrity. And as you so happily put it, you said a key to remember is that sustainability has a social dimension. We have to do you said we have to do what we do safely. So safety first. And your emphasis on using smart technologies, artificial intelligence and robotics to create safer, more efficient construction system reframes sustainability as both a technological and a human responsibility. And the challenges you outlined, from the investment barriers to the governments and standards, are real, but of course, so are the opportunities. So you've helped us see that by embedding intelligence and ethics into the way we build, we can shape cities that are not only resilient, but humane. So not to forget the human side of things. So on behalf of the organizers, on behalf of BISCAR, the Green Institute, we would like to say thank you so much, and on behalf of all our participants, for showing us what the future of sustainable infrastructure can look like. Only that that one that truly integrates people, the planet, and the policy. So thank you so much, Professor Jefferson, for honoring our invitation today.
Well, thank you for inviting me, and I hope you enjoy the rest of the conference.